Hey guys, welcome back. Alright, in this video, I want to talk about scaling. Most models don't understand the meaning of numbers, they only see magnitudes. So, if your features are on different scales, your model can behave very badly. Let's see this in code. First of all, I want to create a new virtual environment. Python 3 v and v. Yes. And source v and v bin activate. Yes. Now let's install the Python libraries. Pipe install scikit-learn pandas kernel and notebook is enough for now. Yes. Yes, this is the end. Now we can create a new Python notebook file and scaling .ipinb and code cells. Okay, this is enough. Yes, here we go. Import numpy is mp and import pandas is pd and from scikit-learn dot preprocessing import StandardScaler and MinMaxScaler and RobustScaler. Yes. Okay, and we can run. Yes. Here I am importing 3 different scaling methods. We will apply all of them to the same data and see the difference. Okay. Now I'm going to create a simple dataset. Firstly, numpy.random.seed 1. Yes. I define data and there's the 2 columns, age and salary, and we can run. And I define div pd.dataframe and data. Yes, let's check the div. Nice. Here I am creating 2 features with completely different ranges. This is actually the situation where scaling becomes important. Okay, go on. I have one question for you. Why scaling matters? Why? Okay, if we train a model on this, salary will dominate age just because the numbers are bigger, not because it's more important. That is the problem scaling solves. Okay. Now I will start with StandardScaler. I define scalar and StandardScaler. After that, scale the data scalar dot fit transform div. We can run Here I am doing two things. Fit learns mean and standard deviation. Transform scales data using those values. So each feature is centered around 0 and scaled to unit variance. This is so important. And PD data frame, scaled data, and columns, div.columns. And hit. We can run. Yes. Now both features are on a similar scale. This is. Now I will try a MinMax scaling. Scaler. I define scaler. MinMaxScaler. And scale data. Scalar data. Scalar dot fit transform df. We can run. Yes. Here I am mapping all values into a fixed range, usually 0 to 1. Same operations like StandardScaler and PD data frame. After that, scaled data. Scaled data 2. We can run. Scaled data 2 and columns, div columns, and hit. We can run. Okay. This is useful when you want abundant values, like for neural networks. Okay. Go on. Now I will use RobustScaler. Same operations and scalar, RobustScaler, and scaled data 3 and scalar dot fit transform df. RobustScaler uses median and IQR instead of mean and standard deviation. Okay, this is so important. And so it's less sensitive to outliers. We can run and PD data frame. Firstly, scale data 3 and columns, div columns, and dot head. Yes. This is useful when your data contains extreme values. This is so important for us. StandardScaler assumes a normal distribution. MinMaxScaler keeps values within a fixed range. And RobustScaler handles outliers better. So, choosing the right one depends on your data. Yes, choosing the right one depends on your data. Okay. Scaling is not optional for many models like logistic regression or KNN. If your features are not comparable, your model is not learning correctly. Okay, and that is it for this video. We will continue in another video. See you there. Bye.